This conference will now be recorded.
All right, hey guys, it's CB Huang again. I think I saw you guys last week or a couple of weeks ago. CV Vorman was supposed to be here, but he's busy with school because it's final season for us. So things are getting pretty busy. All right, so tonight I'm going off of really simple slides that he provided me. So I'll try my best. I'll be doing it on fly, relatively. It's a pilot pun, I guess. Okay, all right. Tonight we're going to describe the production of lift by the aircraft wing, and this would be EOM 231.02. Cool. So a little review. I'm sure you've already heard or you've already learned about the four forces that usually act on an airplane. So there is lift, that is literally making you float in the air, and there's weight, that is literally dragging you down, and there is thrust, that is making you move forward, and there's drag, that is making you more difficult to move forward. So thrust opposes drag, and weight opposes lift. So lift would be like a plus sign, where weight would be a minus sign, and thrust would be a plus sign, and drag would be a minus sign. And in order to lift, in order to actually fly, you have to be able to cancel out weight. So lift has to be greater than weight to gain altitude, essentially. And that comes from Newton's three laws. I don't think, maybe some of you are taking physics right now, and maybe you've heard of little bits about Newton's three laws of motion. But if you don't know, fret not. It's pretty simple. So the first law states that if you were not moving in the first place, you won't be moving, essentially. It's pretty basic. So if you're just standing on the floor and there's nothing changing, there's nothing going on, you would still be standing. And so Newton's second law states, so off of the first law, if you want to start moving, oh, I got a little chat. Yeah, you're going to take physics in high school. Yeah, definitely take physics. Physics is a good subject. Really enjoyed it. Yeah, and so second law states that if you want to start moving, you have to accelerate. You have to give it force. You have to push something to get it start moving, or else it's just going to stay stationary, which makes sense. And there's the third law of motion, is that if you push something, it's going to push you back. If you hit a wall, if you punch a wall, you're going to feel it. It's gonna hurt you, and that's literally the wall pushing you back. And that's how every force is like. So going back to the previous slide, you have to accelerate enough so that you're creating lift more, so that it cancels out weight to be able to actually float in the air. Okay, so airfoils. Airfoils would be any surface that is designed to create lift, that is designed to help you actually fly. So most suitable shape for producing lift is curved, and this curvature is referred as cambered shape. So camber literally means the curvature of upper and lower surface of airplane or aircraft, of an airfoil. I'm pretty sure you've all looked at airplanes and how the wings are shaped. Usually the wings are not symmetrical, like in the first diagram. They're usually cambered, so it's like there's like a little dome on top, and it's concaved in, so it's it looks like somebody has taken a bite off of an apple for the lower part of the airfoil or the wing. And engineers actually designed it to be like this specifically. I'll tell you why. So lift, that force, one of the four forces that is making you actually fly, the lift, is created by an so airfoil creates it by altering the air pressure around it. So I'll give you a simple example. So like I told you, the wing is curved, top, the top part of the wing is curved, and the bottom part is relatively curved, but it's not as curved as the top part. So because the top part is curved, it's actually longer in distance and longer than the bottom part of the wing. And you have to understand that air, the air all around us actually has mass. Air is like fluid, air is like water. And you might ask, if air actually has mass, if it actually has weight, wouldn't you be able to feel? A cool experiment or a cool thing that you can do to actually experience the weight of air. If you have a suction cup, I'm sure you've all played around with suction cups as kids. Let's say you have a suction cup and you push it down the floor, floor below you, and you push it down and you create a vacuum inside. And if you try to lift that suction cup straight up vertically, it's going to be quite hard. I'm sure you've all experienced this at one point in your lives. And that difficulty of lifting that suction cup is actually you experiencing the weight of air. So you're experiencing the weight of air, the column of air that is above the suction cup from all the way from the bottom of that floor that you have. Oh, you haven't? Oh, uh, hmm, yeah. Just try it if you get a chance. It's pretty cool. It's going to be hard to pull it off of the floor. Yeah. Um, and that essentially covers the weight of air, that column of air that is from the bottom of the surface, bottom of the floor to the end of the Earth's atmosphere, which is pretty cool because there's no air inside that suction cup. There's vacuum, there's no air, but then there's still air on top of that suction cup. So that's the weight of air. That's how we know air actually has mass. So air, relatively, it moves like fluid. It's kind of like water. And there's this guy. His name is Bernoulli. He's an old guy. He's not with us anymore. But he had a principle. He made a theory. It says it's the Bernoulli's principle. Essentially, it says if air or if water, but let's say air because we're talking about airplane, if air is traveling fast, it's going to create a lower pressure system. And if air is traveling slower, it's going to create a higher pressure system. So pressure is basically, we have all these molecules, we have all these air molecules, and think about air molecules as little people. Let's say it's summer, it's super hot, it's super steamy, and there's so many people in the subway, there's so many people in this train, and you want to get away from those people as far away as possible, right? Because it's sweaty, it's smelly, it's sticky, you don't like that. That's basically pressure, and air is doing that, and air is trying to get away from each other. So because there's so many people in that train, it's so crammed, you want to get off the train fast, and the only way you can get off is via the doors, right, on the train. But if you want to get out of the train fast, you have to move accordingly. You have to move in a organized fashion. right? If everybody is going for that one little door, you're going to be crammed. You have to line up, and then you have to decide which direction you're going to go to, so you can get out the train faster. So basically, because you're traveling faster, because you're getting out of the train through that door faster, there's lower pressure system because people are not pushing each other. People are actually aligned. People are actually working together, right? So that's basically that. So if air is traveling faster, it creates lower pressure system, and if air is traveling slower, it creates a high pressure system. So the engineers use this principle. So if you look at the wing, the curvature, the upper curvature, like I said, has longer distance. So let's say, and here's another example. I'll call one air molecule Mr. Air Molecule, and the other air molecule Mrs. Air Molecule, and they're happily married, and they love each other so much they don't want to be separated. But then when they hit the front of this this wing, they have to be separated. But because they love each other so much, they want to be reunited at the end of the airplane, right? And let's say Mrs. Air Molecule hits the upper streamline, and Mr. Air Molecule hits the lower streamline. Mrs. Air Molecule has to travel faster because the upper streamline, the upper curvature of the wing is longer, because they want to reunite at the same time at the end of that air. So she has to move faster, and then Mr. Air Molecule doesn't really have to move as fast because he's traveling down the downward air, the wing curvature. So because Mrs. Air Molecule is traveling faster on top of the wing, she creates lower pressure system, and because Mr. Air Molecule is traveling slower underneath the wing, he creates high pressure system. And in this universe, anything that is high pressure, it wants to go to lower pressure, just like the subway. You don't want to be around sticky people all the time. You want to get away from them as far as possible. So it's always high to low. So that's what creates lift, because high pressure is below the wing. It wants to move upwards. It wants to move towards that lower pressure system that is above the wing. That's what's actually making the airplane fly. I hope that makes sense. If you don't, send me a chat. A little. Yeah. If you keep thinking about it, it will make sense. At first, for me, when I was in ground school to get my glider license, it didn't make sense. But if you keep thinking about it, if you keep running into these concepts, it will make more sense over time. So yeah. So when it comes to lift, there's this thing called relative wind. That's the relative direction of airflow with respect to the wing. So it's the wind is always traveling parallel and opposite direction, opposite to the direction of travel of the aircraft, right? If you're going forward, the wind is going to go to your back, basically. And the angle at which this wind meets this thing called chord line, basically that's the angle of how your wing is situated relative to the wind, and it creates this little angle. This angle is called the angle of attack, and I'll tell you more about the angle of attack and what it essentially does. So as the angle of attack is increased, the difference in pressure between the upper and lower wing surface is increased. So this basically means as angle of attack is increased, because you want to fly higher, you're going to pitch up on that stick, and the airplane is going to shoot upward, vertically, like relatively more vertically, and that will make the angle of attack increase, because the air is always traveling relatively same. It's just hitting your face, but then if you look up, the angle of attack is going to increase, because and the mean of all distributed pressure created by the wings is called the center of pressure. So basically, center of pressure, you can understand it as the point where that lift that we've been all talking about is the strongest at. Basically, that's the center of pressure. And as the angle of attack increases, the center of pressure moves forward on the wing, as you can see on that diagram to the right. And the lift factor acts through the center of pressure. Yeah, so as you increase your angle of attack, as you pitch upward, as you want to gain altitude, as you want to fly higher, you want to go up, this angle of attack is going to increase, and that's going to increase the center of pressure. And then actually that center of pressure, it just can't keep going up, right? You're going to meet the limit at which the angle of attack can be increased, or the center of pressure can be increased. This little arrow, this little CP can't go any further than the wing itself, right? And that's when the airplane stalls. If you want to go higher, so you just pitch up, and then you will be the most vertical that you can ever be in that aircraft. You're going to lose all the air that is going to be traveling up on the wing, right? Because you want that air travel up on the wing. Like I said, Mrs. Air Molecule has to travel up over the wing. You are not going to have any air traveling up the wing, so there's going to be no pressure system or difference in pressure that will create lift, that will make you fly, and that's when you fall. That's where you no longer creates lift, and that's where you no longer create lift, and the weight of that airplane just overwhelms you, and you just fall. So that was about lift, and we will talk about a little bit of drag. So drag is the resistance of an airplane, resistance that an airplane experiences moving forward through the air. For an airplane to remain steady flight, there must be sufficient thrust to overcome drag. Like I said, it's the same thing. You need enough lift to overcome that weight to be able to stay afloat, and you need enough thrust, the force that is acting you move forward, that will balance out the drag so that you can actually move forward. If drag is as big as thrust, you're not going to go forward, and there's no point of you not going forward. That would be like in a hot air balloon, but in a plane you want to move forward. That's how you get to places faster than you would in cars. So there's two main types of drag. There's this thing called induced drag. That's the drag that is produced by any parts that are involved in actually creating lift. So these cannot be eliminated. You need these. It's like it's a small price to pay. If you want to stay afloat, you're going to have induced drag. There's nothing really you can do. And there's parasite drag, and these things can be eliminated. And these drags are produced by the parts of the aircraft that do not produce lift. So they can be like fuselage, they can be the body of the airplane, or antenna, or landing gear, all these little bits and pieces that are sticking out the airplane that is making air move not so smoothly. So parasite drag can be reduced by incorporating a streamlined aircraft design. So you want to make your aircraft slick. That's why all the airplanes are really smooth on the surface. Having a retractable landing gear and cleaning the aircraft to reduce screen friction. Yeah, you want your airplane to be as smooth as possible. No ridges, no little pokes sticking out, just as smooth. And induced drag, the drag that cannot be eliminated, that drag that is caused by any parts on the airplane that is actually making you fly or stay afloat, can be reduced though in the design of the aircraft through a high aspect ratio. And then this aspect ratio means longer span and less wide chord. Right. This aspect ratio, you want to utilize this. So in a glider where you don't have an engine, you're essentially falling. You're falling with style. And because you don't have any engine, you want to maximize your flight ability. And in order to do that, you make gliders with super wide wings, super big wings, like longer wings, and you also make those wings thinner, and that will help you reduce induced drag. And another type of drag, it's called the aileron drag. Ailerons, I'm sure you all remember all the little tabs that move behind your wings that actually make you roll to the side. And when you're moving those ailerons, you're going to create aileron drag, and aileron drag will create adverse yaw because the drag created by the downgoing aileron is greater than the upgoing aileron. So if you want to roll to the right, you want to push the stick to the right. So right stick right up, essentially. So if you put the stick to the right aileron is going to go up, and if you push stick to the left aileron is going to move up. And the aileron that is going down, the aileron that you're not, if you want to roll to the right, the left aileron, the left side is going to create drag, and it's actually going to prevent you from rolling smoothly. It's going to actually make you turn to the left when you're actually trying to roll to the right. So these can be solved with differential ailerons and freeze ailerons. I have a little diagram. So the differential ailerons, like I said, the drag is greater for the downgoing aileron. So we make sure the magnitude of which this aileron can move up and down, this move downwards is relatively smaller than the ability of this aileron to go up. Okay. And freeze aileron is basically when aileron is attached to the wing. Boundary layer, like I said, essentially you want those you want Mrs. Air molecule to travel on top of the wing and Mr. Air molecule to travel down the wing, and you want them to be able to travel as smooth as possible because they want to be reunited faster. And this boundary layer, I'm sure you've all seen pictures like in car commercials where they want to show off how streamlined their cars are. So they will have like this fan in front of the car, and they will put like mist around the car to show these flow of air over the cars. And you want laminar flow, which is the smooth travel of air. You want to maximize that. That's going to help you create the lift even more so. And the turbulent layer would be where the air molecules lose speed and they don't travel as smoothly. And the point where the laminar layer transitions into turbulent layer is literally called the transition point. And as the angle of attack increases, as you pitch up and up to gain altitude, the transition point moves forward, and then you'll no longer have any molecule that is traveling smooth over the top of the wing. That's when you fall. That's when you stall, like I mentioned before. I think I ran out of time to do these lesson confirmations. So I don't know, take a look at this. Take a look at these questions and just let me know if anything is bothering you or if any particular question interests you on the chat. Or really any part of the lecture that you maybe want re-explained. That's cool too. The three forces. I wasn't here for that. Yeah, quickly. There are actually four, usually in a typical airplane that you imagine, or a jet, the thing that has a propeller or an engine that makes the airplane go forward. So there's lift, that's actually making you stay afloat, and there's weight that's actually dragging you downwards, so it opposes lift, and there's thrust and there's drag. Thrust is essentially the force that's making you go forward. Drag opposes thrust, and it slows you down in terms of going forward, and you need more lift than you have weight to be able to cancel out that weight and be able to actually gain altitude. And a way to do that is you can travel faster. That helps because more air molecule is going to travel. Oh, slow network connection. I hope you can still hear me, because more air molecules will be able to travel over and under the wing to create more lift. And essentially gliders, because they don't have engines, they don't have the force that is thrusting this aircraft, you compensate your altitude to stay afloat. You're pitching down, you're always pitching down, you're always going down, but then that's going to make sure you're flying fast enough so that there is enough lift to make you stay afloat in the air as long as possible. Sometimes in a glider you can stay up in the air for hours. Actually, they do these things called thermal. I forget the exact name, but there are parts of the Earth's surfaces where it's hotter than other surfaces relatively. So when it's hot, air molecules are more active. They want to move upward because there's no space down the Earth. You find this column of air that is rising, and you just kind of circle around that column, so that one wing is kind of like hinged on that column. So you go up the column. Pretty cool thing to do. Any more questions? Yeah, don't worry about it. If you didn't understand everything that I said in terms of like physics concepts, it's pretty, like I have a bunch of engineering friends who still struggle with like physics concepts. So, but as long as you appreciate it and are willing to learn more about it and be exposed to those concepts more often, you'll be able to appreciate it even more. And it's even better if you actually do like familiar flights or actually experience flying in an airplane, because that concepts come real to you.